Guys, attendance enabled.
So, good morning. So, can you
Good
hear
morning.
me?
Yeah.
So, actually, have a doubt which is not
Sure.
from. Yeah, okay. So, when we are using one's complement, we are just
Mm-hmm.
basically complementing all the values, and that's how we get the negative of the number. But
Mm-hmm.
how are we letting the system know that we are using one's complement?
We letting the system know.
Like,
I don't.
how does the system know it's one's complement? Because like if I'm saying 0 1 1 0 and
Yeah,
suppose
yeah.
it's a number n, and I say 1 0 0 1 is minus n, but 1 0 0 1 can be another number also, no?
Yes. So that is the point. That basically you use the first bit as the sign bit. That if the first bit is zero, the system knows that the rest of the part is essentially a number, and that is a positive number. If the sign bit is one, it means that the number is negative. Now, the problem is I mean, this is the case of signed integers. If it is unsigned, I don't even care, right? I don't care like what exactly is the sign bit. Then everything is positive. So then the concept of one's complement doesn't even arise. One's complement or two's complement representation, it only comes into picture when you have a signed integer. So in that case, you have to figure out a way to represent the negative numbers. So in one's complement representation, we simply say the first bit is the sign bit and the rest is your magnitude. The problem here is that now you can, for what will be the interpretation of 1 followed by n minus 1 zeros. It is basically interpreted as minus 0, right? And that is the problem, that in one's complement representation you are basically wasting a particular bit pattern, because you are having two representations for zeros, plus 0 and minus 0.
And that's where two's complement we just add
Yes.
one so that we
Yeah.
don't waste that
Yeah.
one
So
bit.
when you add 1 to it, then you only get one representation, and that is all zeros.
Right, sir. Thank you, sir.
Okay, we'll just probably wait for 1 more minute or 30 seconds or whatever, and we'll start at 11:05. By the way, when are you guys going to have this computer organization in your curriculum? When is it supposed to be? Anyone knows?
Next sem.
Okay. Actually, it should have been in this semester, in my view. I mean, you usually teach computer organization before. Um, but anyhow, it's like one semester here or there. Fine. Okay, so we should start. What is the total number? Yeah, 81 is good enough. Someone's mic is on. Okay, Palak, your mic is on. Um, Palak. Okay, so let's start, guys. So basically, this lecture is just going to be a very brief revision of C. I'm calling it brief because we are not really going to go into any details. The idea is that whatever we are going to discuss here, these aspects are actually exactly the same with C++ as well. Okay, so and there are actually many others, but whatever we are discussing in this lecture, essentially you can say that even though it is written as a revision of C, it is also equally applicable to C++. And I'm pretty sure you guys, when you had your sessions with your seniors, you already know all these things. But still, just to give a brief overview to those people who may not have attended those sessions with the seniors, whatever we are covering in this lecture, this is actually a part of C, but it is equally applicable to C++ as well. And therefore, we are not going to cover this into our regular lectures. Actually, so from week one onwards, when we actually start the syllabus, we are not going to. I'm going to assume that you already know all these things. Okay. So, what all things do you know in C? So, first of all, we started with these basic data types, right? That you have these int, long, float, double, and char as some basic data types that C provides you to create certain types of variables, right? And out of these, float and double are used for storing real numbers, whereas others are used for storing integers. Char is a kind of a special 1 byte integer where the value that is stored is actually the ASCII value. If you store the ASCII value of a particular character, you can interpret it as a character as well. Okay, so keep this thing in mind that char is actually an integer data type. The only thing that is different with char is that the value that you are storing in that char variable, if that value corresponds to the ASCII value of some character, then you can actually interpret it like a character as well. In addition, you also know that there is a possibility to use the same range. Okay, basically all the bit patterns that you have for a particular integer variable, you can actually use them as as a as a as a positive only integer. So basically a variable that only stores positive values. So in that case, you can also assign a special attribute to an integer type variable called unsigned, in which case the range changes and the total number of bit patterns remain the same. It's just that the range starts from 0 instead of, say, minus something. Now, based on the platform you are using, different data types might actually take different amount of space. In fact, some of you have already tried it out, and you guys probably figured out that I think on Ming, uh, I don't know what exactly is Ming. I actually saw it after some students sent me a query that on certain Windows based GCC versions, you are getting, I think, 2 byte integers instead of 4 byte integers. So that is the idea, that it's not really a constant. On different platforms, you might actually have different values, different amount of space that is taken up by these data types. But in general, on 64-bit Linux systems, int is 4 byte, okay, and then others are basically in comparison to that. So I said like long is 8 bytes, float is 4, and double is 8, so on and so forth. There is also a short. By the way, short, I have not mentioned it here, but yeah, short is usually uh, the only uh, the only thing that the specification of C says is that short cannot be longer, it cannot take more space than int. Okay, it has to be less than or equal to int. So on some platforms you will have short as 1 byte where integer is 2 byte, and if integer is 4 byte, short could be of 2 bytes. That is the idea. There were a number of operators that you guys might have used in previous semester. I think the most common one, of course, was the assignment operator. So with assignment operator, you have on the LHS you have a variable. On the RHS, it could be uh, a combination of variables and constants. Basically, any expression could go on the right hand side, and whatever you write on the right hand side gets assigned to the left hand side. There were other operators like this double equal to meant comparison. It was not really an equal to operator. It was not an assignment operator. It was for comparison, double equal to and not equal to. And then there were things like less than, greater than, less than equal to, greater than equal to. All these operators returned a one. Okay, one as the output if the comparison was successful, and it returned zero as the output if the comparison was unsuccessful. And then you had these common arithmetic operations: slash, star, plus and minus, division, multiplication, addition, subtraction. I should have probably added a percent here. I thought I would have added that. Anyhow, percent operator is, as you guys already know, it's basically the operator for finding remainders. So a percent b is essentially a divided by b, and whatever is the remainder, that is the value of a percent b. Whenever you want to enforce some kind of precedence that a particular expression should be evaluated first as compared to the other expressions, you can use parenthesis. Just put it inside a paired parenthesis, and it should be evaluated first. There are actually a number of operators. We have even seen things like precedence and associativity. I'm not going to go into details of that. They are basically the same. You have to probably look up all those slides and just figure out all those operators. They are basically the same in C++ as well. There are some new operators that are there in C++ that we will study, but all the C operators are there as it is. Now, two most important types of statements that you probably would have written in your programs are the conditional statements and the iterative statements. So, conditional statements are used to change the course of the evaluation in a particular program. So, what I mean by course of evaluation is that, let us say you have a piece of logic that should only be executed if a particular condition is true. Otherwise, those statements should be skipped. So the way to do that is you simply use an if statement. You put the condition here, and then within a paired parenthesis, you can put all the statements that you would like to be executed if this condition is true. You can also add an else. The else part will only be executed if the condition is false. So essentially, either this code block will be executed or this code block will be executed, but not both. And if you have like more than one condition and you just want one of these code blocks to be executed, you can also use something known as just the if else if ladder. So basically you keep on adding more conditions, and you keep on providing more code blocks. Only one of those code blocks gets executed at the time of the program when it is executing. If your conditions are basically based on the values of a single integer variable, integer type variable, so that will include char, int, short, long, all those variables. So in that case, you can also use switch. So in switch case, basically these cases essentially represent the different code blocks in if else if fashion. And um, if you remember, these cases are actually labels, right? I mean, they are not really a kind of code block as such. It is actually a complete the complete switch is essentially one code block, and these cases are essentially labels within this code block. And as soon as a particular case matches, everything below that particular point gets executed, unless you have a break statement. So a break statement can help you exit a particular switch case or a particular loop prematurely. That is the idea of a break statement. The iterative statements are essentially the statements that you use for executing some logic in a repeated fashion, and this repetition has to be controlled in a fashion in some way. So controlled as in it should not continue endlessly. You should have a handle on when to stop. So this is where the loops come into picture. And you actually studied three loops in C. The loops can actually be entry controlled or exit controlled. The entry control loops are those where you check the condition before executing the body of the loop. Okay, so the condition is at the entry of the loop itself. The exit control loops are those where the condition is put at the end of the loop, so your body is guaranteed to be executed at least once. Okay, and the do while loop, you guys already know that the do while loop is essentially a exit control loop. So the reason for this is that the condition is put at the end, right? uh, I forgot to put so there is a condition here, while condition. And whereas while and for, they are basically entry control loops. Okay, so what does it mean by entry control loop? So it's possible that if the condition is false in the first iteration itself, the loop will not be executed at all. With do while, you are guaranteed that the loop will be executed at least once, and after that, if the condition is false, the loop will not execute. And this is the difference that you have to understand, that the do while loop, even though it will execute at least once, um, after that it doesn't matter. After that, it will execute in exactly the same fashion, whereas as compared to, let us say, while or for. So the number of times that the do while loop will run will actually be the same if the value of, let us say, if this number is greater than 1, then these three loops are actually equivalent to each other. With for loop, you also get some nice compact syntax, where you can also do some initialization and the update of a particular variable. Let us say this is the variable on which your condition is based. This is the most common formulation, where you start with a particular variable. It's the loop condition is based on on that particular variable's values, and you update that value towards the end of the iteration, something like that. So for loop is essentially another entry control loop, but here you get some compact syntax to provide these three attributes. In for loop, by the way, you can actually skip all these three. Basically, you can just have two semicolons, within the for declaration part, header part, whatever you call it. In that case, however, if you leave the condition part empty, and this is something that you have to understand, the default value that is replaced if condition is not provided is 1. Okay, so if you create a for loop which only has two semicolons, and you have no mechanism whatsoever to come out of the loop in the loop body, in that case it becomes a infinite loop. And of course, the break statement can always be used in order to jump out of a particular loop from within the loop body. And sometimes it might actually be helpful, because let's say there was some exceptional condition, so there's something that happened in the middle. So in that case, you can use the break statement. But keep this in mind, that the break statement is always applicable to the innermost loop or switch case. So if you have any type of nesting, that is, there is a switch case another inside another switch case, there is a switch case inside another loop, there is a loop inside a switch case, so on and so forth. The loop inside another loop. Uh, in these cases, the break statement will only bring you out of the innermost innermost what can I say, innermost statement. It could be for, it could be switch, it could be do while, it could be while. It will not take you out of the outer one. So keep this in mind. um so we discussed this on Monday, on Tuesday, sorry, that many languages actually do not let you manipulate the pointers directly, right? But C as well as C++, both languages allow you to directly manipulate pointers. And you guys already know that basically pointers are a special type of integer variables which store memory addresses instead of actual values. Okay, and the type of a particular pointer variable is, and in general should be set as the type of the values that you intend to point to. Okay, so if I am creating a pointer with type double star, the idea should be that it should be used for storing the address of a double variable. So the ampersand operator provides you the address of a particular variable. So you can use it something like this: ptr equal to ampersand d, where d is a double type variable, and the asterisk operator is kind of the inverse of ampersand, where you use this operator to get the actual value stored at a particular address. So in this case, you can see that d2 is another double variable, and you are trying to fetch the value that is stored at the location which is pointed to by ptr. So this should of course be the value of d in this case. um, a practical use of pointers, which was quite interesting, was the use of pointers for dynamic memory allocation, right? So you remember that we used these malloc and free functions, not just for creating variable sized arrays, but also during the program or linked list. So actually in C++, you also have a new operator. So sometimes you may not use malloc and free, but yeah, I mean, you can use it, is still there in C++ also. You can use malloc and free. So we in the beginning we started off by calling certain functions which were essentially library functions. If you remember, probably the first library function that we used was printf, then scanf and other such functions. So C provides you with a number of library functions to use, but in some cases where you see that a piece of logic is going to be called, or it is going to be executed multiple times, maybe with different data, then it is a good idea to create some custom functions in your code and add it to your programs. So a custom function, you'll be required to give the declaration of this function if it is being used in your code before it is defined. If it is used before defined, then the compiler needs some kind of a declaration. Now there can be multiple ways to declare a function. The bare minimum of course requires that you just basically give the name of the function and closing parenthesis. But usually the best way to provide declarations is to give a prototype, a function prototype. So the syntax to give a function prototype looks something like this: you give the return type, you provide the name of the function, and then you actually give a list of zero or more parameters, the inputs that this particular function is going to take. Here uh, during providing the prototype, you actually do not need to provide the names of the variables as well. So just a comma separated list of data types will suffice. So for example, here you can write something like int func, and then here double comma float. Okay, so you don't really have to to give things like double D and float F. Just double comma float is fine. Um, and when you are trying, when you are actually providing the definition of the function, you start by giving the function's header. The function header is essentially very similar to the function's prototype, just that in a function header, you also are required to give the names of the variables. So it's just float comma double won't do. You'll have to write something like float f comma double d. And another difference is that with prototype, you actually end the statement with a semicolon. With header, you follow it up by a code block. So a paired parenthesis follows the function header, and within this code block, you write the definition of the function. The return statement is a statement that can actually return a particular value from a custom function. The returned value should ideally be the same. The type of the return value should ideally be the same as the return type that is defined in the function header and or the function prototype. Or it could also be possible that you return a value that can be implicitly converted, converted to this return type. So for example, your return type may be long, but you might actually return an int. So that should be fine. You will not see any warnings, because int can be easily implicitly promoted to a long. But and in functions where you do not have any parameters, you can also provide just a return statement, return semicolon. So in that case, the function simply does not execute beyond that particular point. Now, in C, even though we did study the concept of pass by value and pass by reference, please do keep in mind that in reality, there is really nothing like pass by reference in C. All the values, all the parameters are always passed by value. What really happens is that in order to emulate pass by reference, what we do is that we basically pass the pointer to a particular variable, right? So you understand that it is still a value, but the value is actually an address. So with the help of that, we can somehow emulate pass by reference. In C++, there is a specific concept of a reference. So when we'll study C++, we'll see. But in C, if you have to emulate pass by reference, you have to simply pass the pointers and then manipulate the pointers inside the called function. So this way you can basically achieve the same effect as pass by reference. There are you can either have single variables, individual variables in your C programs, or if you would like a collection of these programs, you had two options. Arrays were basically the collections of variables of the same type. Okay, the length of an array, okay, the capacity, the term that we used was capacity. The capacity of an array remains fixed after its creation. Okay, so it's not like you cannot shrink or expand an array once it has been created. Okay, and the typical syntax was the type of the data type, right? I mean, whatever it is, int, char, float, double, or some structure, the name of the array, and then within these square brackets you put the capacity. And this is like the maximum capacity, by the way. We also defined a term called size, where we were saying that it is possible that the capacity is, let us say, 10, but I'm currently only using 5 of the members out of this 10. So in which case the size is 5 and the capacity is 10. The character arrays, if you are creating an array of type character, they can also be treated like a string if you use the null character. If we put the null character towards the end of your character array, it can also be treated like a string. So all those string functions that you studied, strlen, strcpy, I'm pretty sure you guys would have used all these. It is heavily dependent on the use of the null character. So structures are essentially the collection of variables of different types. Arrays was the collection of variables of the same type. With structures, when you create a particular collection variable, it is called as a structure variable. And prior to creating these structure variables, you need to provide the actual template, the template which describes what are going to be the fields, or the proper term that we use is what are the member variables of this structure. So in this particular case, the syntax is you basically start with the struct keyword, the name of the structure, and then within parenthesis you basically provide the details of all the member variables. The member variables themselves are created in in a fashion similar to creating a new variable. So you write things like int I and float f and so on and so forth. So basically, but you have to give this template first before you can create a structure variable. And similar to the arrays, once a structure variable gets created, you cannot modify its size, right? So you cannot remove a member field and add another member field. All those things are not possible. Once you've created a structure variable, the actual amount of space that is allocated remains the same, and it cannot be changed. When you want to create the structure variables, you can use the syntax struct, the name of the structure, and the name of the structure variable. Now you also knew that sometimes if you want just create a shortcut, you can use the type def keyword as well. So with type def, if you write something like type def struct the structure name, and then some alias, from there onwards you can use that particular alias to create the structure variable. So you can write alias space the structure variable name. So this basically was a very brief revision of some of the concepts that we studied in the previous semester, and they are equally applicable to C++ as well. I actually don't think there are too many differences. There may be, one or two subtle differences that probably you'll come to know when you start with the practice labs. But in general, you should be aware of all the concepts that we just discussed in brief. If you have any issues, please go back and check out the slides from ITP, because I'm not going to discuss it in the class. You can, of course, if you have any doubts during your practice labs, you can ask your TAs. So let us say you get stuck somewhere, you can ask your TAs to help you out. But overall, this is it. In this week, we will start our actual course from next week onwards. Any questions? Okay, so yeah, that was actually a very short lecture. I knew it will probably take only 30-35 minutes. So let me just stop it. Okay, so guys, from we are not going to have any labs this week. Of course, it's already over. But from next week onwards, we will have the labs as well. I will have a talk with the TAs, and as I have already said, these labs are for practice only. If you guys feel that you are well off in C, like in this week's practice lab, I'll give you a simple C question actually, and you'll have to write some code for it. If you get stuck somewhere, you can ask your TAs. From next week onwards, the labs will be in C++. But if you are comfortable enough, because many of you are already well versed in C++, so you can skip the practice labs. Please keep your eye on those dates that I have mentioned in the previous slides. Okay, those dates are going to be our lab exams. So you basically have to prepare yourselves for the lab exams and use these practice labs as a way to prepare for it. Okay, any
So
queries?
lab exams will be like the one we had in ITP last
Yeah,
exam.
yeah. In the beginning, we will start with maybe the first lab exam will be directly on bash, so that you learn how to use G++, similar to how we did it in the beginning, right, with ITP, that first you learned how to use GCC from the command line, and using, like, using switches like minus lm and all that stuff. So in the first lab exam, you will be supposed to show the code and demo on your terminal, but maybe later onwards we can switch to hacker earth. But yeah, the format will be exactly the same. I'll give you a question, you'll have to write the code, you'll have to submit it, and there will be a TA who will take a viva at the end of the submission. Okay, so that it's similar to how you guys have been giving labs in ITP. Any other queries? Okay, so yeah, so from my side, I think this is it. We will formally start with the syllabus from the next week onwards. Please take whatever time is left in this week to revise. I don't think you'll need revision. It's only about 10 days or so since the course ended, so everything should still be fresh. But in case you have become rusty, please have a look at the ITP slides and lectures, and use the next week's practice lab to to clarify your C related doubts, because that will be the last chance you will get to actually clarify on things like arrays and functions and pointers, data types, ranges, all those things, right? I'm not going to discuss them again in the class. When I'll give you the programs in lab exam, I will assume that you already know these things, right? So it's not like the lab exam will only have questions from 1 or 2 weeks, right? It's basically um, everything from C, plus there will be new concepts now, C++ related concepts. And as I have already told you, um, whatever code you have written till now in a C program, you can simply save it as .cpp and run it using G++, the C++ compiler. It should work straight away, right? Because all the C++ compilers, they take C code as without any issues. So C is kind of a subset of C++ these days. So whatever these concepts I have discussed today, I am assuming that when I give you a program, you already know these things. Okay, so I should not hear things like I did not expect a function question or an array question or a pointer question. No, yeah, Priya, go ahead.
It was by mistake, sir. Sorry.
Okay, fine. So yeah, so basically you should know all these concepts. In the first lab exam, you will be required to use all these. Okay guys, so we'll meet on Monday now. Okay, bye.
Bye, sir. Thank you.